So now we'll move on to X-ray. And for X-ray, I have picked this object. Oh, look, it's a fuzzy blob. This is an object called the Crab Nebula. And so the Crab Nebula is in this part of the sky. So here's Orion, there's his belt, there's Betelgeuse, and you sort of go up from there, get to this part of the sky. And many of you will probably be familiar with the Crab Nebula, even if you don't realize it, because the Hubble image of the Crab Nebula is one of the most recognizable, most famous astronomical images, I think. So many of you will have seen, hopefully, this picture before. So the Crab Nebula is what we call a supernova remnant. It's what's been left over when a star much more massive than the sun has exploded at the end of its life. And so what we see here is the gas that's been flung out in that explosion. This is actually a supernova that went off. Astronomers observed it. Chinese astronomers observed it in 1054. They suddenly saw what looked like a new star appear in the sky. And we're waiting for that to happen, actually, with Betelgeuse. So one of Orion's armpits, or shoulders, if you don't want to think of them as his armpits, that star is at the end of its life. And it's a much more massive star than the sun, and it is going to go supernova soon. But when astronomers say soon, it could be tomorrow, it could be in 10,000 years. So no one hold your breath on it. But every time I'm out in the winter, because Orion, we see him in the winter night sky, I do always look up at Betelgeuse just to check that it hasn't gone supernova. Because can you imagine how annoyed you'd be if it did go supernova and you were outside and you hadn't noticed? So keep an eye on Betelgeuse for us. The reason I want to show you this object for X-ray, though, is not to do with this gas that's flung out, not to do with the nebula, but what's left in the center. So when this massive star explodes, the outer layers, as I said, get flung off in the explosion. This is all the gas that we see spreading out now. But the core of it collapses down, and it condenses down, in the case of this star, into what we call a neutron star. So this is a star that's made up entirely of neutrons, of the neutral parts of the atom. And some neutron stars spin, as this one does. And we can actually see that in the X-ray. So I think this is absolutely incredible, because this is the leftover bit of that star. And can you see these two jets coming out of it? This neutron star is spinning, and it's what we call a pulsar. You can think of these as sort of cosmic lighthouses. They've got these two beams that come out, and as it spins, those beams pass by us. It's spinning really fast. This one's spinning at something like, those beams will come past us something like 30 times a second, I think. And they spin so accurately that you can time that beam coming past you. And it's often more accurate than atomic clocks. I can't remember if it is currently more accurate than atomic clocks, because they keep on making more accurate atomic clocks, and then they find better pulsars, and then more accurate atomic clocks. So it's kind of constant battle between the two. But these are ridiculously accurate timers. And this was taken with another space X-ray telescope, the Chandra X-ray Observatory. And of course, we have to put these X-ray telescopes in space, because our atmosphere stops those X-rays from coming down to us on Earth, which is good, because otherwise we'd be fried by the X-rays.